Hello students, today we'll study about the conductometric titrations and the types of the conductometric titrations. Now first we will define what is conductometric titration. Conductometric titration is a method of volumetric analysis based on the change in the conductance of the solution at the equivalence point during titration. Now what is equivalence points? When there is a change in the conductance. And what is conductance? Conductance is the charge or the free ions moving throughout the solution that creates one pore. Okay. Now in this method, the conductance fact of an aqueous solution containing an electrolyte depends upon the three things. The first one is the number of the free ions in the solution. It may be positive, it may be negative. Okay, the number of the free ions. Now the second one, the charge of the free ions. Okay, and the third one is mobility of the ions or the total charge that is moving on. Now there are various types of conductometric titration. Okay. Now the first type is titration of strong acid with a strong base. Now when we talk about strong acid, it may be HCl, H2SO4, etc. And strong base, NaOH, KOH, etc. Okay. Now here we will take strong acid means HCl and strong base means NaOH and see how the reaction takes place and how is the graph. Now this is the graph. Now in the conductometric titration, we have taken strong acid in the conductometric bottle, okay, and in the volumetric burette, we have taken strong base. We will be going on slowly and slowly adding strong base into the strong acid solution that is conducted in the conductivity bottle. Okay, the graph starts from the point A. Point A, that is the solution only contains strong acid. Strong acid has very number of H plus ions that shows the highest conductance should is shown with the A at the high point. See, the graph starts from the high point and it is coming low. Okay. Now when we start from A point, a slowly one drop of strong base is added to the solution. Strong base means NaOH. Okay. Now what we are adding? We are adding Na plus and OH minus. We will split the NaOH. So we are adding OH ions. Now OH ions makes the conductivity less. So the graph will be going down. Each and every addition of the strong base or OH ions, the graph will be going down and it will be reaching to the point B at the equivalence point. This is your equivalence point shown on the x-axis. X-axis is the volume of the strong acid added and y-axis is the conductance. Okay. Now what happens at the point B? The number of charge of the H plus ions and OH ions are equal. Okay. Now further, when more strong base or OH ions are added, what happened? The strong base, the OH ions now acts as a conductivity. It increases the conductivity. So the graph again goes up. We will see the reaction. The strong acid is split into H plus Cl minus. When it is react with the strong base Na plus OH minus, it forms Na plus Cl minus and H2O. Now see, this is the graph where this graph AB is showing the acid reacted with the NaCl form. How the NaCl is formed? It is formed by the addition of the strong base and the reaction of the strong acid. It forms a salt, NaCl. Okay. Now, and this graph is shown with the help of NaCl and NaOH, that is the salt and the strong base. Okay. So, the water is non-conducting and HCl is acid, NaOH is base and Na plus Cl minus is NaCl is salt. Okay. So, this was the first type of titration taking of strong acid versus strong base. So, the curve is higher coming to lower, meeting at the equivalence point, then again going at the higher. So, it is a V-shaped graph. Now, the next type. The next type is titration of the weak acid and a strong base. We know that the strong base, I am taking only the same content so that you can be easily memorizing NaOH. And when we talk about weak acid, it is acetic acid, CH3COOH. Okay. Now the reaction will be like this: CH3COOH plus NaOH. It forms CH3COO minus Na plus, that is highly ionized salt, along with the unionized water. Okay. Now we will see the graph. Now how the graph is? Why the graph is starting from lower end? Because we are taking weak acid. Weak acid has a lower conductivity. So the graph starts from the point A. And each and every addition of the strong base, the conductivity of the solution increases with a slower rate. Okay, not at a higher rate, but a slower rate. So the graph is slightly slanting and it reaches at the point B. What is the equivalence point? With each and every addition of the strong base. Now what happens at this equivalence point? The number of acids and the number of base ions are equal. Okay. Now further, when strong base NaOH is added into the solution, the graph started increasing in a rapid fashion and it is going straight up to an extent at the C. This shows that the Na plus Ac minus will be combination of Na plus OH ions. And here the AB graph is having acidic ions with the combination of sodium acetate. Okay. Now the third type, titration of the strong acid with a weak base. Strong acid HCl. Now coming to the weak base NH4OH. Okay. See the reaction: H plus Cl minus plus NH4OH minus. It will be forming a salt NH4Cl minus. Okay, along with the practically unionized water. Now the strong acid, it has a higher conductivity, so the graph starts from the point A and slowly it goes down by the addition of the weak base. Okay, and the graph is represented by H plus Cl minus along with the formation of NH4Cl minus. Okay, and it reaches to the point B, equivalence point, and then there is a no change, I can say, as the graph is really steady. Okay, why it is so? Because the weak base, addition of the weak base doesn't create higher conductivity. Although when the starting point of A we added weak base in the strong acid, the conductivity lowers and it is a stiff diagram. It reaches to the B, the equivalence point. But furthermore, addition of weak base doesn't create higher conductivity. Okay, so the graph is like this. Now the fourth type and the last type, titration of the weak acid against weak base. Weak acid means acetic acid and weak base means ammonium hydroxide. Okay. Now the reaction is like this: CH3COOH along with the weak base NH4OH, it will be forming highly ionized salt NH4 plus CH3CO minus along with the practically unionized water. Now this NH4 ions and the combination of the highly ionized salt, that is CH3CO minus, when reacts with the weak base, it forms no change in the conductance. Now how this reaction is working in the graph, we will see it. Okay, now this is the graph of the weak acid versus weak base. Up till now we have studied three graphs and the graph starts very steady, and here it is not steady. Okay, it is a slightly curved and then unreacted position. Okay, why it is so? Because it starts from A, the weak acid, it contains only weak acid. When addition of weak base is there, there is a no change in the conductance. But slowly the conductance increases due to the formation of highly ionized salt. What was that salt? NH4 plus CH3CO minus. So the graph is increasing from A to B. But at B, the equivalence point, it reaches and after B it becomes very steady because the weak base doesn't have the capacity to change the conductance. Okay, and the highly ionized salt was formed that remains as it is. So in this video I have talked about the conductometric titration along with its 4 types.